When solving problems like equations sin x equals to negative 0.1, what you do is always draw the unit circle and see where the solutions lie on the unit circle. So here we're talking about sin x, which means a vertical coordinate. Vertical coordinate is fixed at negative 0.1. So you go vertically negative 0.1, and here you draw a horizontal line. All the points on this line have the same vertical coordinate. Therefore, if I take the 2 points of intersection of this line with the unit circle, then here the coordinates are negative 0.1 vertically. So this is cos x comma negative 0.1. So cos x2, and here is cos x1. So so we want to find these two angles, this angle x1 and the angle x2. So what we do is we apply arc sine to both sides of the equation. Arc sine is the inverse function of sine, and arc sine and sine will go away because they're inverse functions, and I'll have that x is arc sine of negative 0.1. Then I plug this in the calculator and I'll get that x is approximately negative 0.1 radians. So then I have to see which of these two angles am I getting via the calculator. Actually, I would plug it in the calculator and see what I get. I always get from arc sine I get this number is between negative pi over 2 and pi over 2. So arc sine always gives me an angle that's on this part of the unit circle. So it does not did not account for, so arc sine and the calculator did not account for x2. To get x2, we notice that it's really it's pi minus x1. So this would be, so x2 is equal to pi minus x1, which is approximately pi minus negative 0.1 radians, which is about 3.15 radians. And then we notice that there is infinitely many more solutions which we get by going any number of full circles around this. So all other solutions are x1 plus 2 pi times n, where n is in z, or x2 plus 2 pi n, where n is in z. And that's it for this first part of the problem. So now we have this problem as well, which is very similar to it, except that the only difference is that you have bigger than or equal sign. This is an inequality rather than equality. So what you do is you look at the graph and see what happens. So to find, oops, let's see, edit, undo resize, Okay, I want to move this out of the way so that we can solve this problem with inequality. So for a prime, what I do is I draw the graph of sine x. This is the graph of sine x. And I draw point negative 0.1. So negative 0.1 is here. And then I draw the vertical line at that height. And what I want is all the pieces of my function where this is bigger than negative 0.1, where sine is bigger than negative 0.1. So I want all these intervals here. They're all solutions of this inequality. And I'm aided by what I did before. This is my angle x1, and here is my angle x2. This is my angle 2 pi plus x1, and here is 2 pi plus x2, and so on and so on. Here is the point angle 4 pi plus x1, and so on and so on. So solutions are intervals of x's such that sine x is above the horizontal line. So one such interval is interval from x1 to x2, and all its shifts by 2 pi, an integer multiple of 2 pi. Okay, so for the second problem we do the same thing, except now we have cos x is equal to 0.1, negative 0.1. So you draw the unit circle, and since cos x is horizontal coordinate, you want all the points where horizontal coordinate is negative 0.1. So I find the point on the x-axis that's negative 0.1. I draw the vertical line. I find the two solutions where cos x is negative 0.1. And to find the exact angle, I'll use the arc cos. So I'll have, this is going to be my first angle, x1, and the other one is then going to be just the negative x1. So this angle here is going to be x2, which is negative x1. So x1 is equal to arc cos of negative 0.1, and then the other solution is x2, which is negative x1. Or you could take 2 pi minus x1 and you would get an integer multiple of the first full circle that's different from this. So arc cos of negative 0.1, you would plug it in the calculator and you would get a certain number of radians. And all other solutions are x1 plus 2 pi n and x2 plus 2 pi n, where n is in the integers, where n is an integer. Okay, if we have a problem like this one, you need to first solve for x. First solve for cos x.